So today, we are gonna go over a few of these because it has been a long weekend. So I know we need to refresh our memory, but typically, remember, it's important that you are doing these. Hopefully you've already had a chance to do these. Eli, if you weren't here and don't have your book, there should be a new book for you up there in the one closest to the fan. So it's suggested that you keep it with you and bring it back and forth, but if you have a hard time with that, you can leave your workbook here. We just suggest you keep it with you because remember, you may be homesick and wanting to follow along. Someone else may take yours. It might get misplaced here, right? All right. So looking at, we did number 1 already. Looking at number 2, remember, we're combining like terms. So if we compare it with this one, instead of turning all the way back to example 1, we can compare it with number 1. Remember, if we don't have a coefficient, we know its identity is one of them. So if it's just an R, its coefficient is 1. So plus this, when they have the same variable in them, we're just adding up the coefficients. So just like we did here, we said this one plus this, and it brought us to this. We're going to do the same thing. We're going to add this one to the ones column, so we simply have 1 and 800 R, right? So be sure it looks like this. Camden, I need you to stop being disruptive. Well, if I see you looking away from where you are, talking, it kind of means you are. All right. So now, number 4, we're looking, excuse me, at all of the terms we have in common. So we started with the first term. Remember, terms are always separated by adding or subtracting, or pluses and minuses. So this expression has 1, 2, 3, 4, 5 terms. Our job is to simplify it. Close your Chromebook, please. So we started with our first term. It has a Z in it. So we circled that, and we circled our other term with a Z in it. Second time, close your Chromebook, please. So we're looking at our coefficients now. Since these are like terms, we can combine our coefficients. So we have an 8Z minus a 9Z. Remember, whatever is in front of it comes with it. So in this case, there's not a plus or a minus, so we assume it's a what? It's positive, right? So what is 8 minus 9? Bless you. What's 8 minus 9? God bless you. Anybody know what 8 minus 9 is? Negative 1. Thank you. So we have a negative Z, right? Because the coefficient there would be negative 1. Then we move on to the next term. Is there anything that we can combine with this X? Is there anything else with an X in it? No. So we're just bringing that down because we have to include it in our simplified expression. It doesn't just go away, right? So now I'm moving on to my next term, negative 5. Is there any other constants we can combine with the negative 5? The 2, right? So what's negative 5 plus 2? Negative 3. So that's our simplified expression. some things we can combine with others, and other things we just bring down, right? If there's nothing like it. So starting on number 5, if you haven't done number 5, please try it. Please try number 5 if you haven't already. Hopefully you have. Combine your like terms. What can you combine with that 5C? Bring it down to your simplified expression. What can you combine with that? Right now we're doing number 5. What can you combine with that 5C? Right now we're doing number 5. What can you combine with that 5C? Hopefully you started off circling your C terms, sign included, right? 5C minus 12C. So we're looking at our coefficients. What is 5 minus 12? Our signs are different. So we find the difference. What's 12 minus 5? You should know that that is 7. And our bigger number is negative. So instead of positive 7, we have a negative 7. And we can't forget about our factor of C. Now, if we combine our next term, all right, so we have a negative 3D. Is there anything we can combine? Any other D terms? Just this D right here. What's my coefficient of plus D? 1. Excellent. So I have negative 3 plus 1. If you're really bad at these, you should probably have a calculator in front of you, because negative 3 plus 1 is negative 2. If you're going to be unhelpful, you can just go. It's not appreciated here. So remember, there is also a factor of D in this like term. And I have one more thing I need to include in my simplified version. I shouldn't have circled it. I should have squared it, huh? It is a negative 6. It can't be combined with anything, so we just bring it into our final form. So don't forget about that. Guys, it's really important that you're understanding this with these whole numbers, because we also need to use what we were just learning about and combine our rational numbers, our fractions. So looking at number 6, my first term is an x term. Do I have any other x terms I can combine with it? Yeah. Yes. So I have 2 x terms. Here's my coefficient of 1, and here's my coefficient of the other. So I have negative 3/4 plus 7/8. Can I add these fractions as is? No. No, so I need to show what common denominators would be. Can 4 go into 8? Yeah. Yes, so I'm going to leave this second fraction as is and change my first fraction into an equivalent fraction to 3/4, but out of 8. So if I multiply 4 by what to get 8? 2. So if I multiply the 4 by 2 to get 8, what do I have to multiply the 3 by? The same thing. What's 3 times 2? 6. So this stays negative. I have negative 6 plus 7, which is what? 1/8, right? So combining these two gives me 1/8 what? X. And now I have to combine my constants. I've got a -3 and a -1/2. So -1/3, I said -3, didn't I? -1/3 minus 1/2. What's the least common multiple of 3 and 2? 3 times 2, right? So 3 times 2, so 1 times 2 is what? 2. And 2 times 3, so 1 times 3 is 3. These are both negative, so it's getting more negative. So what is -2 minus 3? -5, and our denominator stays the same. So is that a bit trickier? Yes, it definitely requires some more steps, but we still should be able to do that. All right, number 7, it looks like we're starting with our constants. Remember, constants do not have a variable in it. Remember, variables are letters. So if there's no letter in that term, it's a constant. So I have to add 1/4 and 7/8. Well, over here, I changed my 4th to 8ths. So don't you think that's what we're going to do here? So 1/4 plus 7/8. So I have to multiply the top and the bottom by 2 again. So this time I have 2 8ths plus 7 8ths, which is equal to what? 9 8ths. Sorry, I'm getting rid of that equal sign because this is bothering me. So 9 8ths. I'm just going to leave it improper. And then my y terms I need to combine. So looking at this, looking at my coefficients, the number in front of my variable is my coefficient. What's a common denominator of 5 and 10? 10, right? So to get 5 to turn into 10, I'm going to multiply it by 2. So that's what I have to do to the top of my fraction. So I have 9/10 minus 3 times 2 is 6, and 5 times 2 is indeed 10. So what is 9 minus 6? 3/10. And is it positive or negative? Positive or negative, guys? Positive, right? So I just have to write plus, and what else does my 3/10 need? It needs its variable back, which was y. So either 3/10 y plus 9/8, or 9/8 plus 3/10 y, or 1 and 1/8 plus 3/10 y would work too, right? All right, so if you have not done number 8 yet, try that. I want to give you some time to try that. Start with your first term, combine them. You have to find common denominators, which means you need to know that 2 can go into 6. So you can change your denominators to 6. Try that. Number 8. So we're going to combine that with that. So how do I change 1/2 into something out of 6? We're going to multiply the top and the bottom by 3. Bless you. Hmm? So combine your like terms. Some of you did this already and are waiting patiently. Thank you. Some of you haven't done this at all. Some of you are trying it. So thank you for trying it. So these terms are like terms because they both have an A in it. I can't combine this term with something without an A in it. But I can combine my -1/2 with my 5/6. So I would multiply the top and the bottom by not 2, but 3, because 2 times 3 is 6. So I have -3/6 being combined with 5/6. And that has an A term connected to it, right? So what is -3 plus 5? Hopefully you got 2/6 A or 1/3 A. Because you could divide them both by a factor of 2. And then we're going to combine our 2/5 with our -1/10. So I can change this into a denominator out of 10 by multiplying the 5 by 2. So that's what I have to do to the top. So 2 times 2 is 4. 5 times 2 is 10. Minus this 1/10. Well, 4/10 minus 1/10 is 3/10. So that's going to be in my final answer. And is it positive or negative? It's positive. So be sure you include that these are being combined, right? With that plus there. Okay. So remember, in Reveal, if you want extra practice, you can always go into our lesson 5.1 and you'll be able to be walked through more examples, more checks, more practice problems. So use that as a tool if you need it. So now I'm going to turn back. We are going to learn how to use the distributive property, which once you see it, you'll be like, oh, but if you choose not to do it, it's hard to learn it. So you do have to still do things to learn them in math, right? So the distributive property can be used to expand linear expressions. You learned about this property hopefully in an earlier grade, but it just states that to multiply a sum or difference, so here's a sum and here's a difference, be multiplied by a number, each term inside the parentheses is being multiplied by the number outside the parentheses. So they're saying A times B, and they're writing that as AB. And then they're bringing in this sign, so that plus carries to here. And then they're saying A times C and writing it as AC. So with numbers here, they're saying 4 times X is being added to 4 times 2. And they're simply simplifying it. So we know 4 times X can be written as 4X. And we know that 4 times 2 is 8. Okay, same thing here. We just have to pay attention to the sign a little bit. So A times this B can be written as AB minus, that sign just kind of carries over here, A times the second term, which is C. So A times C can be written as AC there. All right, so showing you the way you're going to see it. When there's a number touching that parentheses, it needs to be distributed through. That's why it's the distributive property. So we have to multiply it by all of the terms within the parentheses. So we have 3 times X and 3 times -5. So that's what this is saying, 3 times X and 3 times negative 5. Or in other words, they just carried this over and said 3 times 5, which is still this negative 15. So 3 times x is 3x. It brought the negative sign down, and 3 times 5 is 15. So if we were to fill in the boxes to model the distributive property here, this 2 has to be multiplied by the x, and this 2 has to be multiplied by the second term, which also happens to be 2. And then they just want us to simplify. 2 times x is simply 2x, and 2 times 2 is 4. That's all we have to do here. Now, they're saying this 4 is being multiplied by the first term, so that's what they're putting here. And it's being multiplied by the second term, so that's why they're putting it here. Now, when we have a coefficient, we're saying 4 times a negative 3. So we have to multiply that term by the coefficient, and then we just have x next to it. So do you see how 4 times negative 3 is negative 12? But we also have to include that factor of x next to it. So that makes it a little bit trickier than just 2 times a variable, right? So 4 times 6 is 24. So in other words, they just want us to rewrite that 4 times negative 3x is negative 12x, and 4 times 6 is 24, and that is positive. So I put a plus in between because they're being combined. Now, these are not like terms. I can't combine them and say that that's 12 or 12x or anything like that. One has an x in it, one does not, so I cannot combine them and simplify any further. That's as simplified as it gets. So I want you to check your knowledge of this. Remember, you're saying 9 times negative 5a, and then you're saying 9 times 3b. So we're always looking at the coefficients, but we can't forget to bring down the factor of a and the factor of b into our final answer. So try that. So we have 9 times negative 5a plus 9 times 3b. So we're looking at our coefficients. 9 times negative 5 is negative 45, and that's being multiplied by a, right? This is kind of like 3 factors here. This times this times this. Plus, I'm bringing that down. 9 times 3 is 27, and that's being multiplied by a factor of b. So we've kind of been preaching neatness, preaching making sure your numerals look like what they're supposed to be. This b starts to look like the number 6, so do be very careful there. So this would be as simplified as it gets. We can't combine these coefficients because one has a factor of a in it, and one has a factor of b in it. Okay? And it looks very similar with subtraction. So they just rewrote this as addition and attached the negative to the coefficient. So that's why I always want you to think of subtraction as that number being negative. So even though this 3 is at the end of the parentheses, we're still multiplying it by the 2 to get the 6x. and we're multiplying it by the -5 to get the -15 here for the y, okay? And then we'll typically skip this step. If it's negative, we write minus that. If it's positive, we write plus this. So in other words, when we distribute it here, 3 times 2x, well, 3 times 2 is 6. That's being multiplied by a factor of x. And then 3 times -5 is -15, which is being multiplied by a factor of y. So use the distributive property to now expand this. So we're saying 5 times -4, right? And 5 times -7. So try that check on page 238. So hopefully this is quick, right? What's 5 times 4? Well, it's 20, but our signs are different. So we have a -20 connected to that W. And 5 times 7 is 35, but our signs are different. So it's -35. Now just adding one more little layer here. Sometimes we're distributing a negative through, right? But you know how to multiply your integers, hopefully, right? So now instead of a positive factor being distributed through, we have a negative factor, but it's still going to be -5 times this 2x and -5 times this -9. So -5 times 2 gives us that -10, and it's being multiplied by that x. And -5 times -9 is a +45. So that's why they're saying that when you distribute this -5 through, you get -10x plus 45. So try that check as well before we move on to finish the practice. Make sure you know that you're how to distribute that -6 through. So -6 times -8y. And then -6 times 10. So here right away, negative times a negative, you should say, oh, that's going to be positive, right? 6 times 8 is 48, and that is being multiplied by that factor of y. Negative times a positive here is going to give us a negative what? What's 6 times 10? 60. So hopefully now we've got some time. We should be able to finish maybe even the last 7 on page 241. We don't have too many problems and we're just multiplying through. So distributive property to expand each expression. So remember, you're going to multiply all terms by what is touching the parentheses. So it might be touching the front of the parentheses, it might be touching the back of the parentheses, but that's what you're multiplying through here. Right? 2 times negative 3x. I should say 2 times negative 3 is negative 6 being multiplied by a factor of x. And then 2 times 5 is 10. What do I need between them? A plus, because it's positive, okay? Number 12 is very similar, but you're distributing the 4 through. 4 times negative 2 is negative 8x. 4 times negative 7 is negative 28. Guys, if you don't know how to multiply those quickly in your head, yes, it does make you have to use a calculator or your multiplication table or something, right? So multiply those through. That leaves you with 5. In at least 5 minutes. Should be quick. Out of the way, keep going. So you multiply that 60 with 6 times negative 4. What's 6 times negative 4? Try to use what you know about distributive property to rack your brain for number 15 as well. So page 241 should be complete after today.